Hey guys, it's Josie with Queen My Pawn, and I got a math question today from someone named Matthew94. So thank you, Matthew, for writing to me. And he says, "Hey, Queen My Pawn, I am really struggling to understand trigonometry about those sines, cosines, tangent, cotangent, secant, and cosecant. It would be really helpful if you can make a video like that. I know the basics of finding an angle using two sides in a right triangle, but I definitely need more help understanding." Well, Matthew, I'm glad that you wrote to me about this question. So here's a typical situation. Suppose that you have a ladder on a wall, right? There's actually a wall like this, and let me draw it as straight as possible. Well, I tried. And then you have a ladder, which is not in blue, but I'll try this one more time in white. And then you have another line, which is like this, but starting from the floor. Now this is the ladder, and it's in green. And they give you two distances. The first distance is from here to here, which is the floor. It's the ground. And this is the wall, and this is the ground. And if the ladder is 5 meters long, which is about like 16 feet, which is a pretty good sized ladder, to reach to the top of a house, a two-story house, then the ground has maybe like only a length of 2 meters. That way you could actually reach the roof. So I'll put ground equals 2 meters. So in the end, what angle must this be? Which I'll denote it by theta. It's a letter. So the ground is basically all of this, and it's 2 meters long. And you have to find that angle. Well, you know that the hypotenuse is the green, and you know that there is a way to find out that angle, but you have to know this shortcut. So ka toa, which means the sine equals the opposite over the hypotenuse, the cosine equals the adjacent over the hypotenuse, and the tangent equals the opposite over the adjacent sides. So which one of these do you think it could be that we have to use, and why? So I'll give you 3 seconds to try to pause the video and find it out for yourself before I continue my explanation. Well, I hope you gave it a shot, because if you did and you get it wrong, then you know where you can improve on and why. So definitely make sure to give it a try. And if you did, good job. So if this is that hypotenuse side, the ground is adjacent to the angle, so it has to be C, as in cosine, equals adjacent over hypotenuse, because this is the angle. The angle is adjacent, in other words, touching, in other words, next to the ground. So we're going to basically do this in yellow. The cosine of the angle equals the opposite, the adjacent, which is the ground. So I'll put the ground over the ladder. Adjacent over hypotenuse. The lengths then have to be 5/2. No, sorry, 2/5 because it's adjacent over hypotenuse. Okay, and in the end, you're gonna get the cosine of the angle, and I'm gonna have to go all the way to the left of the screen. So you get cosine of the angle equals 0.4, but that doesn't tell you much. Now, you have to do this operation where you do the opposite function, the inverse function of the cosine, which is cosine to -1 on cosine of the angle equals, and remember, when you do to the left, you got to do it to the right. So then we do cosine to the -1 of 0.4. See how this in red right here is the same thing as this? We just did something to each side. It's like if I have, this is an object A, and that equals another object B. So it's like I have A equals B, and I'll write it one more space. But then I do something like C -1 of A equals C -1 of B. That's what I did here. That's just applying the inverse. So then you put that in your calculator. But what you should get is not some weird number, because there's a difference. Make sure that your calculator is set to degrees and not radians, because I'm going to share with you right now a screen where you can see what happens if I put the wrong thing. Cosine of 0.4, and watch what happens. So here I put cosine of 0.4, but if you do this in Google, Google automatically reads it as radians. So you need to put and make sure also it's negative. So cosine, and the way of doing that is basically cosine -1, and the arc cosine, basically, because that's the opposite. So what I do, instead of putting that in Google, since it wouldn't read it, I just put arc cos. And I have to make sure that it's not in radians, but in degrees. And it's 66 degrees. Perfect. After all, it wouldn't make sense to have some weird angle like 1.15. Like, if you can think of that in your head, 1.15 is like very, very, very tiny. And obviously, if it's very tiny, like you got the ladder, which is 5, but then you got like this very little distance on the ground. That doesn't make sense. It makes sense that it's 66 degrees. But more importantly, let's see something with easier numbers to work with. And here's what I mean. Bear with me as the screen is going to turn temporarily white. So here is something very cool. And this is a shortcut to remember all the time. 1, 2, 3. Take the square root and divide by 2. This is basically sine of 30, 45, and 60 degrees. Now, if you put sine of 30 degrees in your calculator, you should get the square root of 1/2, which is just 1/2, which is just 0.5. So we've concluded that sine of 30 degrees equals 0.5. And for the 1 of 45, you should get 0.707 or something similar. And for the third one, I think it's, I can't remember the third one off the top of my head. Just put this in a calculator and you should get something similar. So for cosine, it's the other way around. So for cosine, it's basically 3 over 2, 2 over 2, and then square root of 1 over 2. Okay, so basically what we've done is just turned it all around, okay? And then tangent is just sine over cosine. So you just divide this over this. So in the end, you should get something like this. 1 over 2 divided by the square root of 3 over 2. Now, when you divide fractions, this cancels out. And so basically, this equals 1 over the square root of 3. But in math, you don't really put square roots on the bottom. So just multiply both sides by the square root of 3 over 3. And you should get, in the end, the square root of 3 over 3. And you do the same thing for the other ones. So actually, you could see that when you divide this by that, what should you get? And don't do this with the calculator and see what you end up getting. Okay, so before I continue, did you get 1? If you did, then that's a good sign. So get it, it's a good sign. I cracked myself up. You divide something by itself. So like queen my pawn divided by queen my pawn is equals 1. Josie divided by Josie equals 1. Chess divided by chess equals 1. Okay, and similarly for this, when you find the tangent of 60 degrees, it should give you the just the square root of 3 over 1. So you have this cool little chart. Square root of 3 over 3, the 1, and this is just the square root of 3. So we've created a cool little chart, and it's actually a table, if you want to call it that. And you can verify this for yourself. It's true. So again, 1, 2, 3, take the square root, divide by 2. In that order, and that'll give you sine. Then you can find cosine by just going backward, and then tangent is just sine over cosine. So that's it, really. I hope that helps, and feel free to like the video. Feel free to subscribe for more videos. And any comments would be greatly appreciated. Like if you still have some trouble understanding, I'll improve on it in the next video. And I'll see you in the next one.